Hello. We are back with our week two. And in this week two, what we are going to discuss is all about this week two, all these lessons and all. I'll not just watch any videos. You can follow along. And how to follow along, I have, given that in part one or week one. So you can just directly go and watch that portion where you can just follow along. All right. So shall we start? Well, I think we should. So lesson, art of solving problem. So in this lesson, like week two, we have to discuss all about Karel. Like there are multiple things that we might just discuss for the assignments, but there are other things as well that we can do with the Karel. All right. So I'll try to discuss it as well in the last portion where it's optional and all, but I'll try. All right. So we are at here. By the end of this lesson, you'll be able to decompose, which is an approach, which is to approach a problem up down. Like break down the problem into smaller chunks and solve those smaller problems first. And that will result in solving the bigger problem that you had. Now, combined with the arts of stepwise refinement, test as you go. All right. So let's continue. I'll not be watching this video, so let's continue again. So here is a warm-up challenge and example. So you can review Karel and loops. Well, for loops, I have already talked a little about loops in week one, all right, while loops and for loops, but we'll see that over here as well. Now for the world, we have this world, we are over here, and we have to go over here. That is our goal. So to do that, we have to turn left first of all, so that it faces northwards. Then we have to move so that faces, so that it goes upward by one. And then we have to, turn right, but we don't know, or the Karel don't know how to turn right. So we have to turn left 3 times, and that is equivalent to turning right. And then we can say move, and yep, we did it. Next. Now here is an example code for what? So let's first of all, run it. All right, just increase the speed a bit. Okay, so we are sort of creating a diagonal or sort of, doing the stepping up motion. You'll know what I mean by stepping up. If you have watched the video, you already know what I mean by step up motion. All right, so this first line, what it implies. It means we have not written the Stanford Karel. Stanford has written the Stanford Karel library, and we are importing everything, every function out of it and using it in the main. So this line only signifies that. All right. So from Karel.Stanford Karel, we are importing every function, everything. Now this is a warm-up example that makes, Karel place a diagonal beepers line, and it says recall how while loop works and practice stepping up. So this is, stepping up motion. We are going to use similar sequence of commands a few times today. All right. So we have only 2 functions. First of all, it's main function where we write everything. And this is where the program starts from because, we make it start from main in line 26 and 27. This only means that we want our main function to be the starting point of this program. And then this can be sort of an assistant function or sort of helper function for us, because Karel doesn't know how to turn right. It only knows how to turn left. But we can create a loop, or we can just say turn left 3 times. So we, instead of saying turn left 3 times, that is, that is a repetitive process. We are writing a loop so that the repetition could be reduced and we could make it much more efficient. So we are saying the same thing, that is turn left 3 times, but in a loop. And one thing I want to just make you recall, we use for loops where we have a definite number of things we want to do. Like to turn right, we have to turn left 3 times. That is a definite number. We have 3, right? Let's say we have to move 4 steps. We can use for loop, right? Because we have 4 steps only. Now, while loop is something which is based off a condition. So if a condition is true, it runs. If condition becomes false, it doesn't run. Is that clear? And running the while loop means that it will run the while loop. It will check for whether the condition is true or not. If it is true, it will go inside this indented code and it will start running these indented commands. And if the while condition is false, it will not even go there and not even try to read what the command says. It will just skip this whole while loop and come to the next command, whatever it is. So for now, it is put beeper. All right. So we get an idea where we use while loop, where we use for loop. For loop is where we want to do something definite. We have number for that. While loop is something we want to do, but with a condition. that is either true or false. And conditions can only give us true or false. And this is a condition. So it will only result in either true or false. All right. So let's see what it does step by step. So we all know, first of all, it skims through the code or go through the code very quickly to just get an idea around what is there in the code. So it goes through every function and everything very quickly. And now it sees, yo, this is where we should start the program from. So it goes from line 27 to directly the main, and it is inside main. Now it starts to run each and every command that we have. So inside main, the first thing we are trying to do is we are checking. So inside a while loop, we are first of all checking for the condition that either front is clear or not. So for now, front is clear, which means front is clear will give us true. So we can run the next command, that is put beeper on line 12. Yeah, so it tries to run line 12 and it puts a beeper. Then it turns left. And so it is turning left. We are not able to see it. Yeah, see, it sometimes gets stuck while turning and all. All right, then we want it to move one step, and then we want it to face east, which means turn right. So it will turn right, and it doesn't know what turn right is. We have defined turn right on line 19. So it goes through the line 19 and sees a loop, and it tries to run it. And the loop is nothing but turning left 3 times. So we'll see it runs turn left 3 times. This is 1 time turn left. This is 2 time turn left, and this is the last and final 3rd time turn left. And now our Karel is facing east, or it has turned right. Now we'll go back to line 15, and because it has been executed, we'll go to line 16 and execute that as well. See, line 16, that is to move, and we move. And our while loop has, completed 1 cycle. Now it checks for the condition, whether it's true or not again. Now front is still clear, so it will run all these commands again. So let's just fast forward it. Now it still sees, still checks whether the front is clear or not. It still is. So we'll fast forward. And again, it checks whether front is clear or not. It is still clear. Now since the front is not clear, it is going to escape our this loop and come to the next command that is on line 17 and just put a beeper there. All right. If we don't put a beeper over here, it will not put the beeper at the last position because, the front is not clear. So it will not put the beeper because of line 12 says it, because it does not even execute the line 12. It just goes out of this while loop because front is not clear at all. And so it is sort of called, this position is called off by 1, where we have to do the last thing, like putting a beeper, or let's say we were doing something else, we would have to do something outside of this loop. So we'll see this off by 1 many times in a code, and you just need to remember we do something like this, where we do some action inside a while loop and it gets remained, or it leaves 1 step behind, that is to put beeper again. So we have to do it outside of the loop. That is off by 1. All right. And after finishing the problem, it goes to the blank line or the last line that is in a program and says, yeah, we have finished the program. So you can continue. Again, not going to go through this lesson, but we can see the chapters of the textbook because it helps. Okay, so I thought this would be the same book. It looks same, but still looks a bit different. I don't know why. All right, so we have a program that is quite nice, I'll say. What it is doing is collecting all the beepers and placing it at one place. If we run it, it's nice. Now, if we try to see what it is doing in a main, so it has a limited amount of beepers in a bag, or let's say it has 0 beepers in a bag, and it is collecting first of all the beepers and then putting it over here. But what if we had unlimited number of beepers in a bag? Now that will become something that we have to somehow be able to count how many beepers are there. And that's through a recursion that we'll talk about at the end, because it is not in our assignments for now. All right, so let's go back and continue. Not going to watch this also, but it is pointing towards the same stepwise refinement book. No, this is different book. Like, this is Karel Reader. This was also Karel Reader. I guess it must have been a bit different, but I think the content remains the same. Yeah, the content remains the same, but we can see all the codes over here. So this one is nice, and all these links will be there. Yeah, mostly the descriptions and all. Now we can continue. So this is our example code. Now we have to see, and it is going out of this screen. Yep, now it's properly visible. So what it is doing now, let's go through it again. So we are importing every function for Stanford Karel, and then we are writing main. So in main, we are writing only 3 functions. That is to climb up the mountain. It somehow knows how to climb up the mountain because we have defined how to climb up the mountain. So it climbs up to the mountain. It plants a flag there. That is to put a beeper, isn't it? Yeah, plant a flag is put a beeper. And then it climbs down. So to do this, we mostly see where we are at and where we are going to be after we finish the same thing. Like if we climb from here to here, the condition that changes between those two is the thing we are going to use. So like what changes? The first thing I can see changing is whether the front is clear or not. So it'll check whether the front is clear, and if it is not clear, it will probably move upwards by 1 and try to step up by turning right and then moving so that it steps over here. Then front is again not clear, so it'll try to move up and do the same again. And when it reaches the peak where the front is clear, it will probably stop. Now to step down, we see that front is always clear except for this place where the front is no longer clear. So we are going to run opposite, saying while front is over here we would say front is blocked because front is not clear, and as soon as front becomes clear it will stop. And while climbing down we can say while front is clear we can move, and as soon as front becomes blocked it will stop automatically. All right, the second thing we could have said, I don't know, but you can try, definitely give it a try. Like if left is clear, you can try climbing up or sort of ascending. And to descend, what you can do is move till the last canvas over here, and then try to move forward as soon as the front is clear, or let's say the right is clear, whatever you want to. So there are multiple ways to solve one problem, but you should always choose the one you think is intuitive enough for you so that you can solve it. All right. Now climbing up the mountain, we are doing the same thing. That is to, while the front is blocked, that means over here, and over here, we should try to step up. Step up means we should go one place above and ascend to a step. So it's like a step up that we have defined, and it is just set of motions. That is to turn left, move, then turn right, which is something we define. That is turn left 3 times and then move again. So we are very familiar with this sort of motion and conditions. So we can do this easily. And then it does step up and it will stop over here because front is no longer blocked. So it will not try to step up. And if it tries, it will probably crash, but it will not. All right. Then we plant a flag, that is to put a beeper over there, and then we have to start climbing down. That is, if front is clear, we try to step down. Now step down is again a set of motions, that is to move, turn right, move, and turn left. We are very familiar with it as well. So we'll do that, and as soon as the front is no longer clear, it will no longer try to step down, and so we have climbed down very easily. And now the last condition, well, this is not a definition, it is just our helper function, and that says turn left 3 times. All right. Now let's try running it at once with a bit of a speed. And now let's see what it does step by step in the code. A little more back. So it first of all tries to skim through each of the definitions that is there, and then it tries to climb up the mountain. And in climb up the mountain, it sees a while loop, which is checking for a condition that front is blocked. And for now, it is true. So it will run this while loop. That is nothing but step up inside this while loop. I'll do set of motions. And to turn right, it has gone to turn right to, turn left 3 times in a loop. And after turning right, it will come back and it will move. Again, it is checking the while loop's condition that front is blocked, and it is, so it will try to step up again. So let's see. Now we are very familiar with how it steps up. So let it run. All right. Now again, since the front was blocked, it will do the same. Now it has stepped up, and while loop is checking for the condition, and now it is false. Like front is blocked is absolutely false because front is clear. So it will not try to step up. It will just, say this function has been finished. So let's move to the next one. That is to plant a flag. So it tries to plant a flag, which is nothing but put beepers. It will put a beeper. And then it starts climbing down as soon as the plant flag gets finished. Now climbing down is again over here with a while condition and a set of motions. So while condition, front is clear, absolutely. So it will try to step down. Now step down is nothing but set of motions. That is to move, turn right, move, and turn left. And it has step down. My bad. Now again, it checks whether the front is clear, and it is. So it will try stepping down again. Now it checks for, while front is clear again, and it tries to step down again. Now this time, the front is no longer clear. So this loop will also stop, and it will go to the last line, which is for now main. At main, if there was a line 53, it would go to line 53 probably, like the last line of the program, indicating that this program is finished. We have executed everything. So we can continue because now we are very familiar with what it does. All right. Good job. Now I'm not going to go through this video, but let's see if there's another book that we get. No, we are seeing the same link. So probably the same book, which is this one. Still, let's see. So yeah, it was the same book, right? So I'll probably link these 2 books. Okay. Now this is, clearing out all the beepers that is, spread all over our world. So Karel will just move on row by row for each row and pick all the beepers if there is any. Now how it does that? Let's see the code. So this line, you're already familiar with it. Just speak out loud what it is and we can move on. Now definition of main, where we start executing our main thing. Why? Because we have defined it at the end that main is where the program should start from. Now while left is clear, all right, which means it will go till left no longer is clear. So if it is over here, left is always clear. If it is over here, left is still clear. If it is over here, Karel is over here, left is still clear. If it is on beeper over here, left is still clear. But if it is over here, left is no longer clear. It is the boundary of the world, so it cannot go beyond it. All right, so left is no longer clear over here only. So it will probably stop at this place. Now what we are doing while the left is clear. So while left is clear and Karel is over here, what are we doing? We are first of all clearing row and then resending to the next row. So what clear row does, I'm assuming it goes through the whole row and picks up any beeper it finds in the way. So yeah, if I see what the clear row does, it has a while loop saying while the front is clear, which means till here, it will clear corner, which is another function, and then move. But over here, the front will no longer be clear, so it will not be able to clear the corner, which means we have to say clear corner again for the last corner. What is a corner? You might not be familiar with, or you might be familiar with if you're watching the videos. But corner is nothing but all these plus signs where Karel and beeper can be placed. All these things are corner, each of these. Like in an Excel, you have a cell, isn't it? So in this Karel's world, we have a corner where the row and column intersect, sort of that way. All right. So it tries to clear the corner, the last one as well. If we don't, if we run it without, clearing the corner over here, we comment it out. It will probably not clear the last corner if there is a beeper present. Right now it is not, but over here it will not probably clear the corner, the last corner. So let's not do that. We are very familiar with off by one problem. So this is that off by one. Now what clear corner is? So clear corner is nothing, but it is trying to check whether a beeper is present, and if beeper is present, it should pick up the beeper. So it is assuming that there will be only one beeper at one place. There can be three or more beepers. So we should probably use, if beeper is present, while beeper is present, pick the beeper, something like that. But still it works, and we are assuming that there is only one beeper over here. Now, after going through the whole thing and assuming Karel is over here, and we have finished our program successfully, this clear row, we can now reset to the next row, which means going back over here. Let me draw something instead of saying here, there, and all those things. Let's draw. Yeah. So Karel goes this direction, checking if beeper is present, and if it is, it picks up the beeper. All right. And after, clearing the row, it has to reset to the next row. So it comes back and it turns, if it is facing westwards, west, it has to turn right, not left. So turn right, and it has to move. So it is on the next row, and it has to face east. So it will probably turn right again, isn't it? Yep. So now it has resetted to the next row, and then we can again clear row for this one as well. And it will clear the whole row, and it will reset the position as we did. So it will go and reset the position, and we will clear this row as well and reset the position and do the same thing again and again till we go to the last one, that is over here, because now no longer the left is no longer clear, so it will probably stop. But for the last row, we've said clear this row again, but outside of this while loop. If you have noticed, I'm talking about this one, clear the row. It is also called fence post problem in this CIP. All right. So I think it is time to, see this code running. Let's see. So run. Yeah, it goes and now comes back, goes and clear the corner, comes back, do the same, comes back, do the same, and it comes back. And for the last one, last clear row, it does that. If we try to see what it does one by one, it first of all skims through the whole code, right? And now it runs the while left is clear, which it is. So it will clear the row. So it goes to clear row, and while front is clear, which it is, it will try to clear corner, which is nothing. If beeper is present, it should pick up the beeper. That's it. Move again, clear the corner. Now, since beeper was present over here, it picked up the beeper. All right. And now it should reset to the next row because, front is no longer clear and it has cleared the whole row. So it has to reset to the next row, that is this function. So we shall see how it resets. So it turns around, which is nothing but turn left 2 times. So it turns left 2 times and then move to the wall. Move to the wall is another function that we have made that runs for while front is clear, it just moves. So it moves and now it is facing westwards and front is no longer clear, so it will stop. And then it says turn right, so it will turn right to face north, which is nothing but turn left 3 times. And now it is facing right and it will move. It is facing northward. It is just stuck in this position right now. So if we say move, it has moved upwards. And now we have to turn right so that it faces east again. So yeah, it does that. And we are back to clear the second row. And then we'll clear the third row and so on and so forth till we are over here. Now left is no longer clear. So it'll probably run the last clear row, which is this one, line 16. Is it stuck? No, it is not. So you see what it did. It first of all checked whether the left is clear, but left is no longer clear. So left is clear says it is false. So for false, while loop does not work. So it goes to the next command, that is to clear this row, because we know this is the final row and we need it to be cleared up. So it clears this row as well by the same action and we are done. It has cleared the whole thing. So we can continue. All right, so that's all. And it says, if you have time, check out the word search code, which is, I guess, a video. And we should skip this video. So yeah. So mark this lesson complete. And reading was just this stepwise refinement, which is the same content, but different links. I don't know why, but still, it's nice. Now mark this lesson as complete because we have completed it. Let's go to the next. That is Stonemason Karel. Stonemason. Yeah, let's see. All right, so we are at Stonemason Karel. Let's make it full screen. No distraction at all. Yeah, so Stonemason Karel is a problem where we are the masoneries and we have to, create these pillars, I would say. So over here, the beepers are our stones and we need to use them to create pillars. Now let's start by how will we build a pillar. Let's start very basic. All right. So how to build pillar. So the first thing we need to do is, wherever the Karel is starting, because Karel is starting where we need to, build a pillar, the first pillar. So we shall just start building a pillar. So we will turn left, that we know we can. And then we'll do something that is, put beeper. And after putting beeper, we should move. And let's see what it does. Yeah. So this is a great step, I would say. And can we move till the last thing? So there is a condition, if we remember it correctly, that is front is clear, isn't it? So if we are facing this way, that is north way, this is up front. And till this wall appears, we need to move and put beepers. So we can say, while front is clear, we can probably move and put the beepers. So this will actually do the whole thing at once. Yeah. What is the issue now? Why didn't we build the whole pillar? Why did we leave the last one? Again, this is fenced post problem, or we can say off by one. I like to say off by one. Again, what we need to do is put the beeper for the last position where the front is no longer clear, but we need beeper there. So this will actually finish the whole pillar. And yeah, it did. Now we can have two strategies. The first one, let's, draw instead of just saying here and there. So the first one is to just, make it turn right and move to the next place where we need to build pillar. And since there are, in uniform positions, like we need to move 4 times. And then again, we need to move 4 times from here to reach the next one. And again, 4 times, isn't it? 1, 2, 3, 4. Yeah, it is. So I think we can either move from bottom, like make the Karel come back and then move, or we can just directly, move from here as well and build a pillar. But I would say, just make Karel come back and go from here only till we build all the pillars. Now, if you're thinking like let the Karel go from here to here and then build the pillars top down, over here it was built bottoms up, if I can say that. It is built top down, then we have to move like this, and then again build a pillar, move to the next one and build a pillar. So there are two ways to build the pillar. That is, first of all, bottoms up, second one, tops down. Now, this one is way efficient in terms of, using unnecessary movement. So Karel will not do any unnecessary movement. It will just build the pillars, and we can do this very easily. But to, make it much more, I would say snappy, I would just like to build pillar as a one function and then let it come back to the position where it started from and let it move there. And we can use the same function again to build the whole pillar and then move to the next one, build the whole pillar again, same way, move to the next one, build the whole pillar again, same way, and turn face east if possible. That's it. This is going to be my strategy. You can do this problem any way you want, and there are multiple ways you can do it. So we have built a pillar. Now we need to come back, a sort of reset. All right, so to reset, we'll say turn around. Now it doesn't know what the turn around is. So let's define two functions that we always need. So that is to turn around. We'll need turn around multiple times, and we'll probably need turn right as well. So we can define turn right as well. Turn right. Now to turn around and turn right, we can directly say turn left 2 times or turn left 3 times, but I would like to just use for loops because we already know how to use it. For I in range. Now this is a syntax you have to follow. Now in range of what? To turn right, we have to use 3 times and do what action? We have to take action that is to turn left. Not we, it's Karel that is turning left. And all right, we can say something like this. Now to turn around, instead of, turning left 3 times, we should turn left 2 times. I think we can use turn around now. Now to turning around, we can move while front is clear. And we can put a beeper there. No, we don't need to put beeper. Sorry, I'm way sorry. We just need to move till the end. So just move. And that's it. It will probably start from here, build a pillar, come back here. And we need to just adjust its orientation to face east. That it is not. It is facing southwards because it was coming down. And this looks hanged up. But all right, we know it has been moving southwards, so it is facing southwards for now. And we need to say turn left to make it turn or face sort of east. And just to check whether it is facing east, we can say move. See, it is facing southwards. Let's see what it does. It should build a pillar and move 1 step after that. And it does that. All right. This is nice. Now, instead of saying build pillar, instead of to build pillars again and again, let me demonstrate what I'm trying to say. We can say something like move, 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 which will work. It will move 4 times and it will go to the next position where we need to build the pillar. Let's speed it up. Okay, so it goes over there, but we can use for loops to move to the next position. So we can just say for I in range of 4, we need to move. All right, so this is clear. It will do the same thing again. Yeah, it did the same thing. But now to build a pillar, do we need to copy this whole thing and paste it over here again? Yeah, we can do that. But see, copying and pasting is something that is very error prone, which means we can make error at any point of time. And we don't want to make errors at any point of time. So we can just create a function out of it. If you know what I mean, I'll just cut this and we'll create a function that builds a pillar. So we can say build pillar, and this will build a pillar. Now to define it, we can say def build pillars. Oh, build pillars, and paste the whole code. It builds the pillar, right? Now, what will happen? Tell me. So this will build first pillar, then it will move to the next position for the pillar, and that's it. That's where it stops. Now, since there is, I guess, only one world over here. Yeah, there's only one world, and that is a definite world. We need to build pillar 4 times. We can directly run it on a loop, or we can just copy paste this again 4 times. And I'll tell you this again. We hate copying pasting, because copying and pasting is error prone. See this indentation error. If you didn't notice it, it'll probably cause an error. Now this will do it. But, we don't like copying pasting as much as we can, as we know about. And the last one does not even need to move. All right. But let's run it in a loop for 4 times. How about that? We'll say for I in range of 4, let's build a pillar. What is it? A typo? Oh, so there's I. You need to change a variable, that is a. Just change the variable and it will do the same thing. Now there's an error that is front is blocked, and we were trying to move, which we should not. But all right. There's a bigger problem than that. To move, we can, instead of moving, we can move safely. That is safe move. And we'll define what safe move is. Let's solve it first of all. Safe move is nothing but, if front is clear, then only we can move. This is safe move. So if front is no longer clear, it does not move. This is one way to do it. But let's say, what if we wanted it something like more dynamic? Like the world did not need only 4 pillars, it needed, let's say, 14. We can increase it from here, and that will do it. But what about we can, instead of doing, changing the numbers, what if we could use another loop, that is a while loop, where we know a definite case, that is while front is clear, we can build a pillar, while it is not, we should not. So we can do something like while front is clear, we can, try building a pillar, and when it is not, we cannot, or we should not. So it again builds 3 pillars and stops at the last one because front is no longer clear. We can build the last pillar by saying build pillar again over here, and that will do this assignment again. Now you were lucky that it was facing east, otherwise we could have a different problem sort of. But now if we want a 14 pillars, or let's say 100 pillars, we don't need to change anything at all. It will try building the pillar till it reaches the end of this world where the front is no longer clear, and it will build the last pillar over there, and that's it. All right. So I think since we have finished it, let's move forward with the next one. So stonemason Karel was done. Let's fill Karel. Now fill Karel is an, well, I would say interesting movement assignment, because what we are doing over here is putting beepers and moving certain ways that we have already known how to move. But again, this is interesting, and we'll try to do it properly. So to move without knowing how many times we can move, like I think there are multiple worlds over here. So some world is like 5x5, some world is 3x4, some is 2x2. Like we cannot directly say for I in range of 5, just move. We cannot. All right. What we can do is run it in a while loop, which says while front is clear, we can try moving. and it will move the same amount of time, or sorry, uh, it will move till this last wall for every world. So if we try running it, yeah, it does that for 5 by 5. It does that for 3 by 4. It does that again for 2 by 2. And that's the beauty of while loop. We don't know what the definite number of movement is, but we know for a certain case it should move. That is, while the front is clear, it should just try to move. All right. So the strategy we'll be using for this case, let's discuss that first. So we'll try to move forward, all right, by putting beepers and moving, putting beepers and moving, and put the beeper for the last one. We'll come back, reset to our position home, then we'll move to the next one, that is the next row, and we'll try to do the same thing again. All right. So it is interesting, and it sort of seems repetitive a little bit. So let's use loops as much as we can. So let's move as well as put beepers as well. We need to fill the Karel or the world of Karel. So put beepers. So this will fill the whole row except for the last one. So we need to do that over here outside of this loop. That is off by 1 or fence post problem. Now if we need to, make it much more dynamic, or I want to reuse this part of code again and again, instead of copying and pasting, I could probably make another function saying fill row. This seems nice. And we can use the while loop over here. And for n number of times, we can call fill row and it will probably work. Now, every function needs a parenthesis, so we should not forget that. All right, so if we run it, it will do the same action. But now the code is much more like dynamic, where we can, use fill in row again and again. But before filling the row, because front is no longer clear, so it will not do anything, we should reset the position to come back and then move to the next one. So we will create a reset position function, but let's do it first of all in main, reset position. What reset position is, let's see. So we should first of all turn around. Now again, we need two helper functions, that is turn around and turn right. So we'll create them as well right now at the end. Over here, I'll say something like helper function. And we can create two functions, that is turn around and turn right. Now we know turn right is nothing but turn left 3 times. So we can write that. And we also know that turn around is nothing but turn left but 2 times. So now we have created turn around and turn right. We can use them. So our Karel turn around, which means it is now facing westwards. It should move till the end, which is while front is clear, it should try to move. Which means now it is at the last position over here, facing westwards. Now to move upwards, we need to face north. That is, we need it to turn right, isn't it? Or is it turn left? Well, let's see by running it for the first time. Yeah, so it moved to the next one, but we need to, make it face east now so that it can fill the row again. So to make it face east, it is facing north right now. It is stuck up in east position. That is just a problem we see. Now it is facing northwards. It already was. So now we need to make it turn right again so that it faces east. So turn right again so that it faces east. And after this, we can call fill row again. This should work. So yeah, it did work, and we need to reset position again. And to reset position, well, either we can copy paste this or just create a function called reset position. And creating one function is much better than copying pasting, because we don't like doing the same thing again and again. That is copying pasting. And why don't we like that? Because it is error prone, which means we can make errors, human errors. Now, this is looking much nicer, much clearer of what we are doing. The intention is very clear. We are filling the row, we are resetting the position, we are filling the row again. So let's run it. It'll do the same thing. Let's make it a bit faster. So it does the same thing, but now we have a problem. But just a way to think, like, how can we fill all of these rows? Can we, copy and paste and do the same thing 5 times? Or should we run it in a for loop? Or should we choose a while loop? Well, if you thought we should use while loop, I think you are right, because, we are going to do that for 3x4 as well. We are going to do that for 2x2 as well. So if we try to run for 5 times, run this 5 times, we'll face problems in these small worlds. And if we try to keep it minimal, we'll face problem in bigger worlds. So we need a dynamic loop, that is while loop. So for while loop, what condition can we use? There are many conditions. Which one should we use? Well, it is, filling the row, resetting the position, doing that again and again till it reaches the end where the left is no longer clear. So we can use while left is clear, we should do this action, and as soon as left is no longer clear, we should stop. So it will probably fill out till this position. Yep. And now we are back to our fence post problem, or off by 1. What can we do? Fill the last row. As we know, it is at the last row. So we can fill the last row and we are done. And we did it. So let's move forwards from fill Karel. So spread beeper section is another problem. Let's see. So for week 2, we have art of Karel. So let's read the handout. Okay, so over here, we have to, spread beepers. Now to spread beepers, we have many ways, like using loops and all. And you can probably come up with a loop and you'll probably able to use it. All right. So we have a problem that we have a pile of beepers and we need to, well, fill out all these beepers. Like if we have 4 beepers, we need to fill 4 corners with the beepers. And that's it. Now there are many ways we can come up with, filling up beepers, like using while loops and all. But you can do that for yourself. Like, yeah, just try filling out the beepers using while loops. It is not very difficult. But now I'm going to tell you something much more interesting, that is recursion. Recursion is something that was very hard to wrap my mind around it. So even I took, 5 weeks to just get around what recursion is. Now recursion is nothing but using a function inside itself. And I'm going to describe it a bit more. But before that, let's see a real definition for recursion. All right. So we see that recursion is a programming technique where a function calls itself directly or indirectly to solve a problem by breaking it down into smaller, manageable subproblems. And it relies on two essential components, a base case, which provides the stopping condition to prevent the infinite loop, and a recursive case, which defines how the problem is reduced in terms of itself. Right? And there are multiple algorithms and things that we use recursion for. Now, recursion is a technique where it tries to loop, but we can take benefit of recursion to even count the beepers directly and spread it out. So that's a way. Let's give it a try first of all. So to spread a beeper, we need to first of all move on the beeper. So to move on the beeper, we need to say move. After saying move, we are already on the beepers. Now we need to somehow spread all the beepers that is there. So we can probably try using while loop. Let's use while loop. While beepers present, what we can try to do is pick beeper. It will pick the beeper. It should try moving. So we'll try to move and we'll put the beeper back. All right. So let's try using while loop first of all. So it does that, but now it's stuck because, as soon as it puts the beeper, loop ends and it is already on the beeper. So we can try adding a move again. And since it collided with the front, we can use two conditions simultaneously using an AND condition as well. So AND front is clear. All right. So if beepers present and front is clear, then only it will try to pick beepers and move and put beepers and move. All right. So let's see what it does. It picks the beeper, it moves, and that's it. That's what it did. Now we need to somehow go back to the pile. So we can say something like return to pile as a function. And now we can try creating return to pile ourselves. So let's define return to pile. That is nothing but turn around. Now we need to define what turn around is, but all right. After turning around, while the front remains clear, we should try to move so that we reach this end over here. And since it is facing westwards, we need to turn around again so that it faces east and move again so that it is on the beeper. And we can do this pick beeper, move, put beeper again. All right. So this is what I think I should do. Now what turn around is, let's define that as well. Turn around. Turn around. Turn around is nothing but turn left two times. So for I in range of, let's say 2, turn what? Turn left, isn't it? Now we should also try defining turn right, because I think I'll use it, which is turn right is nothing but 3 times. All right. So I think we should be able to run this and let's see what it does. So it picks up the beeper, put it there. It picks up another beeper and puts it there. Oh, so it is now piling up at another place, which is not what we wanted. All right. We didn't want this. So what we can do instead is remove this last move because it is not doing much of anything right now, I guess. Yeah. And it is not doing anything. So instead of just moving one step, we can say, while beepers present, so that we can escape all the beepers that is there. And I guess we have escaped all the beepers in a problem, I guess, where we were standing on the beepers and we need to get out of a place where the beeper was there. So we needed to move out of the beepers. If you remember that. while beeper present, we can try to move, that is this, and put beeper again. So let's see. All right, so it is getting stuck at the last position where it is trying to, return to the pile. What can we do? So it should be like, if beeper is present, then only you should pick the beeper. Otherwise, you should not. So can we do something like if beeper is present, pick beeper? Which I think is already it's doing. So I don't know. Let's do this. Let's keep it a little fast. Okay. So we need to somehow stop it so that it doesn't return to the pile and do this movement again and again. That is returning to the pile again and again. So what can we do? We are stuck at the same position. So we have to do something in return to the pile. So we should turn around, move, turn around, and move. All right, this is what we are doing to return to the pile. And we should return somehow restrictively. Let's undo this. So it picks the beeper, it moves while beeper is present. We should also say if beeper is present, then only move. Otherwise, don't even try to move. All right, now let's see. It's still stuck. So see, let's try to see what it is doing. So it is returning to the pile, which is, all the steps. Turns around, moves. And while beeper is present, which it is, it tries to pick the beeper. While beeper is present, okay. This is where we are getting stuck. It puts the beeper directly there as soon as it, gets out of the loop. So what should we do with those put beeper? Because it is going to put beeper over here, which we don't want to put beeper. What can we do? All right, so I think we should try doing it inside this while loop. So let's try that. I think that will... No. We are then putting beeper. Let's do it else. Like if beeper is present, try moving. If it is not, put the beeper. But then it will put the beeper and beeper will be present, so it will keep on running. So not this again. Okay. Let's just see where it starts to return. I think we can get a clue from there. Let's see. So it always returns, from the beeper. Like, let's go back, go a little back. Yeah, so it is on the beeper and it tries to turn around and move, move till it reaches no beeper. So if no beeper, it stops, and front is also clear. So yeah, then it turns around and then it moves. That is returning to the pile. Now let's say if pile is empty, that like it has picked up the beeper, and it has picked up the beeper, and now it is trying to move, which it cannot. And we are putting the beeper, and then we are doing the same thing again and again. How can we stop? Okay, so I got an idea. I just got an idea. Like, we pick a beeper, right? And we move, and we do the same thing that we are doing. But what if we picked up the beeper, and if beeper was no longer there, we should not move and even put the beeper. How about that? So let's try doing that. So we are trying to pick a beeper, and instead of writing it over here like this, we should do this. And if beeper is present, let's try to say if beeper is present, then only move and put the beeper. How about this? So if beeper is present, then only try even moving and put the beeper. Otherwise, don't even try this. And return to the pile. All right. So yeah, it returned to the pile where the beeper is no longer there. All right. So what we should do for the last one is put the beeper ourselves. So we can put the beeper there because we know this is the last beeper we are going to put. And it no longer returns to the pile. We can directly say, return to the home. So we can create a function that is return home. And we can define it like this. And at the end, we can directly say just return home. All right. And to use it as a function, we need parentheses. Let's try running it. Yeah, we absolutely did it. And this was actually using loops. And let's call it spread because, this is spreading. So just say spread. Let's define spread. And this will work the same. And yeah, it does. So we did the same thing using loop. And if I just remove all these useless lines, we can see how many lines of code we actually used. And it's a lot. Let me tell you, it's a lot. We are not going to use these many lines to, spread the beepers recursively. So let's, instead of using spread, how about using a recursive spread? So we'll create recursive spread, and instead of returning home right now, let's just create recursive spread first of all, where we will use recursion, and I will explain what recursion is, what base case is, what recursive case is, and yeah, let's see that. So let's define recursive spread and just notice the difference of how many lines we just use for recursive spreads. So recursive spread, in recursion, we call the function itself inside, so we call the function inside itself. So we should do something like recursive spread inside recursive spread like this. Now it is not very well defined, like what should we do, what is the base case, what is the recursive case, but we know what the recursive case is. Let's see. So base case becomes if beepers present. If beepers, somehow present, just try to do something that is recursive spread. That is, pick the beeper. So we need to pick the beeper, and if beeper is present, then only, recursively spread, which means pick the beeper again. Imagine, all right, let me, get a blank slate just so that I can make you visualize. So imagine in recursion, you're a spring, and spring goes on and on and on inside itself, coiling itself around, and it coils till the base case is satisfied. And as soon as the base case is satisfied, it starts to get uncoiled or unwind. And so it does all the actions that just remained there. So it unwinds very quickly. All right. Just imagine to do recursion, we are first of all saying, hey, first of all, pick the beepers. So it's like if there is a beeper, instead of drawing, let's just create a text. Let's just say, hey, pick beeper. If I can make it a small. All right, so it tries to pick the beeper first of all. And then, since it knows that after picking a beeper, what should we do? We should check if beeper is present or not. If beeper is still present, we should call a function, our function that is there, which is recursive spread. We should call it again. Where? We should call it inside itself over here. So we'll call recursive spread again. So we will call recursive spread, which is nothing but pick beepers inside itself. So it is trying to pick beepers and do something else as well. So it is doing something else, but we don't care about it because there's also condition there as well to check if, if beeper is present. And if beeper is still present, if beeper is still present, we can call the recursive spread again and again and again. And so this thing goes on and on until and unless beeper is no longer present and we have picked all the beepers. And if we have picked all the beepers, we can try moving forward, and then we can try putting the beeper after moving. Does that seem nice? If it makes sense, well, let's give it a try. If it doesn't, it will start to make sense after you see what happens. First of all, let's see how it picks up all the beepers and it just runs out of the moves. So our recursion is working because, we don't see that recursion exceeding any steps. But if we don't use this base case, if we just call recursive spread inside itself, it will probably exceed the recursion limit. Let's see. See? So what is it? It says no beepers to pick up. So the code has an error and it stopped running. So it tries to pick beeper, and pick beeper, and it cannot. It cannot pick beeper because, there is no longer any beeper to pick. So the base case is necessary where it stops as soon as beeper is no longer there. And then after base case, we can start, if it starts unwinding, we need to do some certain movements, that is to move and put a beeper. Let's see how it runs. Okay, so it worked actually, but it just moved one step forward. So let's put beeper first and move after that. Let's see. Let's slow it down a bit so that you can probably see what is happening. So it picks up all the beepers, you see? And now it starts to put beepers and move, put beepers and move, put beepers and move. So it gives us something like Karel is able to count the beepers where it cannot, but it is using recursion to actually count the beepers. We are not actually getting how many beepers are there, but it knows that I've picked, let's say, 4 beepers. Let's put beepers again and move a step. Put beepers again, move a step. Put beeper, move a step. Put beeper, move a step. 4 times. That's it. So that's recursion for you. If you still cannot get it, remember, even I was not able to get it, and I got it after watching certain videos on YouTube and reading the definition again and again. So try reading it 3 times. And there's a YouTube channel called Computer File. I remember something like Computer File, and they have recursion, like they have covered the topic recursion in quite a depth. And there are 2 to 3 videos, I guess. So you can go and watch them. It is very short, 10 to 20 minutes at max. So yeah, this was our assignment. Let's go back. Since we have finished it. No, we have not finished it because we have to return home as well. So let's do the return home function that we have made. And we did it. But there are certain things I would like to, let you know, like please create comments, because if I, go back and don't watch this code, it's fine. But if I come back to this code again, it'll be like a curse. I cannot understand a few of the moves and all, like why I did it, what was the need, and all those things. So please try to write comments as much as you can. Please do not follow my footsteps in that case. I probably sometimes write comment, sometimes I don't write comment. It is a good practice to write comments so that you can understand what you write, or even others can understand and try to collaborate. All right. There was the same problem, but a bit advanced. Let's see. All right, so this is the same sorry. All right, so this is the same problem. Let's retag. All right, so this is the same problem, but a little bit more advanced, because we are not just spreading beepers for the one row. We are also spreading beepers for as many numbers of rows as possible. Now let's start by doing one row again. That is to first of all, move to the beeper, move to the pile, I would say, and then recursively let's use recursion. Since we understand what recursion is, you could use the loop as well. You could just copy paste the loop one, the spread function from a previous code. That will work. Let's use recursive spread. Let's use this, and it will recursively spread it. And let's come back home. So return home. How about that? Or sort of reset position. No, return home sounds nice and warm. I'm bad at naming things. Just remember that. I'm quite bad at naming things and all. Now, what we need is to define 2 things. That is, define what the recursive spread is, and then also define what the return home is. Now, there's a syntax that is pass. We can use the pass when we want a function, but we don't want to define it yet. Like, I don't want to define return home first. I want to first of all define what recursive spread is. All right, so let's do that. Let's also define our helper functions like turn around and turn right. Turn around, this is for I in range of 2, isn't it? Turn left. And I want this copy and paste it over here. For turn right, I would just say 3 times turn left, and this is it. Now we can try defining recursive spread. It is nothing, but it tries to pick the beeper first of all, because it is on, it is on the pile. So it tries to pick beepers, BEE. and PERS, pick beepers. And then it has a base case that is, if beepers present, then only, repeat recursive spread again and again. So if beepers present, then only try recursive spread again and again. All right. And let's put beepers and move to sort of spread the beepers. Put beeper and move. I hope this works. There was no turnaround used yet. It will be used. There was a typo. That is, instead of beepers, it should be beeper. Is there any other typo? No, there is not. Now this works and it looks good. Now we should define what return home is. It is nothing, but it should just turn around first of all. And after turning around, it should move while front is clear. So while front is clear, it should just move. So it is facing westwards and it is, going to the left side over here. And then we need it to turn around so that, it is facing east now. And it has returned to the home and reset it to the position. All right, so this looks nice to me right now. But this only works for the world 4. Let's go to another world and see what happens. So let's go to world 1, 5, 2, 6. Now, if we run it, it only does this, recursion spread for the first row. But we need it to go to the next row and the next row and the next row. What we can do, what we should do actually, is take this and cut it, because we should define something that is repeatable. We don't want to repeat all those 3 commands again and again. Whereas we could, but we should not. But let's do it anyways. All right. Then after it works, we'll try to, create a function out of it. Yeah, because when we are solving problem, we mostly focus on solving it anyhow. So I'm imagining it will, do the recursion. It will spread the beeper. It will come back home. It will try to climb up. That is, move to the next row. So we'll create move up, or sort of ascend. All right, so we can do that. Now to ascend, it has to first of all turn left, since it is facing east. After turning left, it should move. And then to face east again, it is facing northwards right now. It has to turn right. So we'll say turn right. And again, it has to do this move, recursion spread, and all those things. All right. So we can say while left is clear, we should try doing this again and again. There's a typo, that is, there's no colon. Always use colon. Oh, yeah, since left is clear, it'll do this, go upwards, do this one as well, go upwards, do this rows as well, move upwards. Left is no longer clear. We need to repeat something, that is to spread. Let's see. What is the typo now? Turn right. Oh, always use parentheses for a function, and turn right definitely is a function. So it does it, moves to the next one, recursively spreads it. Will it move to the next one? Yep, it does move to the next one. And move to the next one. Now over here, it is not recursively spreading it. So we need to, do this step again. So that's why I was saying, create a function out of it. That is, we'll define spread row, isn't it? Spread row. So we know it will recursively spread the whole row, but no recursion is getting used in this function. There's a function that is recursive that is getting used. All right, there's wrong indentation. Now they should work the same. If we say spread row over here. All right, and to move upwards, let's create a function that is called something like ascend. isn't it? So let's define ASCEND, ascend. Let's make the indentation properly. And after spreading the row, so while left is clear, it will probably spread the row using either while loop or recursion. We are using recursion over here. No need to worry about it. We have made it abstracted so that we don't care how are we spreading the row. We know we are spreading the row successfully. And after spreading the row, we should ascend. And left is clear, so it will do the same thing again and again and again till left is no longer clear, which means over here. Let's do. Let's make it a bit fast as well. All right. So for the last one, we can just call spread row. You know, you're very familiar with this pattern again. It is off by one, or we like to call it the fence post problem, isn't it? Again, it was off by one. It was not able to spread this row, the last row. So we'll do it. The problem is still not finished. It needs to go back where it started from. So it has to reset. So I'll just create a reset function. Or since it is just getting used only one time, we can just, instead of creating function, let's just write it down right over here. So it is facing east. We need to turn right to make it, face south. And then, oh, sorry, we are not defining. And then we are not defining what's happening to me. All right. So since we are facing south now, so while front is clear, what we should do is we should move so that it is over here back. And then it should, to make it face east, again, we should turn left. So if I run it, let's see what happens. Yeah, it comes back and we actually did it. So in our section, there was two problems. First one was to spread beeper. The second one is to spread multiple beepers. Nice one. And again, I would suggest you to write comments. It is very necessary. I don't follow those because, well, I need to save a little bit more time, creating videos and all. So spread section beeper is done. Let's go to create your own Karel. And well, I have already created my own Karel, that is created my own flag, and I made a video on it as well. So just check out the playlist and you will find this video as well. As for how it runs and why it looks so repetitive, well, it is not. It is a little bit, but it is not. And just see what it does. I'll make it faster. And it'll create the Indian flag. It is a very pixelated flag because, we are using Karel. But in week 5 with graphics, I'll actually create a better version of Indian flag. So just stay tuned. Yeah, so it is completing it and it is done. All right. Now there are two things I would like to, if possible, I would like to make change of. First of all, don't like these. I don't want to write these like quotes. And it was like, I wrote it 5 to 6 weeks earlier. So yeah, it makes sense why this looks so bad, I would say. The second thing I would like is like turtle. If you have ever used turtle in MSW logo or in Python, you can hide the turtle. So I somehow want to hide Karel after it finishes up the flag because, looking at the Karel is not a part of flag. So that's the second thing I want to change. The third thing I would like to say is, please, Aditya, please write the comment. I am telling myself, I forget. I don't like writing comments because I do not come back to my codes again and again, and I don't have anyone to collaborate with. So, all right. Now we have optional challenges. Now these are the worst nightmares and the best thing you can do in code in place, because these were the challenges that took my nights away. So the midpoints and the checkerboards, damn, these problems, they were hard. So if you can't get it the first time, well, just rewatch it, try it, rewatch it, try it, rewatch it, try it as many times as you want. There is no restriction at all. Just at least get started with these optional channels. They are quite hard. But since we are here, we'll make it probably quite easy. I think I would. I assume I would. Let's see. So we have to find the midpoint somehow. Let's start from 6 by 6, because let's start from 5 by 5, not 6 by 6. This has started from 6 by 6. So can you tell me where the midpoint is? Just by counting it out. Well, it is nowhere. It is, half of 6 is 3.5. So it should be around here or here. Now I'm not sure where. So let's start from 5, because you can see where the midpoint is. It is right over here, isn't it? So let's start from here so that we don't get confused. As for this, just remove this. All right. So I know of 2 strategies that we can take, and I'll only take one of these strategies. As for the rest 2, you can try it out on your own time. So the 2 strategies are like, first of all, just climb up, like stepping up on stairs, and you just have to accomplish going at the furthest end, like diagonally. You have to go there. You have to reach this diagonal. All right. And to reach this diagonal, you have to step up and all these actions. Now you need to come back after 2 steps and something in this pattern, and you might have probably reached the midpoint, and you can put a beeper over here. And I don't know how much this works because I've never tried it, but you can in your own time. As for me, what sort of thing I will do is, I'll first of all fill all these row with the beepers. Then I will I'll just, walk back and forth, and I'll try removing all the beepers till it just remains on the last midpoint, and I'll put the beeper there, and we are done. So again, what I am doing is the second one. As for the first one, you can take on that strategy and take it as a challenge and try to do it. So we should start by filling all the rows. So how to fill up the rows? We already know it. So we use the while loop, while front, because there are different sort of worlds. We cannot just directly go there and put a beeper. So while front is clear, we should put a beeper and move. So it'll probably, fill up the whole row. Except for the last one, again, it is off by 1, which is fence post problem. So now it does fill the whole row. All right, this looks nice. So we can create a function called fill the row for the first time and define it over here, because we don't want complications at one place. It will become a mess soon enough. All right. So first of all, I'll try to write comment, because otherwise it will become incomprehensible. Yeah, incomprehensible. So we have to fill the rows with beepers. And after filling the rows with beepers, we now have to remove beepers from far ends. So remove beepers from the far ends. And to remove the beepers from the far ends, let's create a function. All right. Shall we do it over here? Let's do it over here. No. It will become a mess. So let's create a function. Let's create a function called remove beepers far end. And this is quite comprehensible, I would say. So let's define remove beepers from far end. All right. Now, how shall we start doing this? Like how to remove beepers from far end. So it's like we have to pick beepers. If I say pick beeper, this is how we should remove it. Does that make sense? Little bit, I guess. So it'll go fill up the row. It'll pick up the last beeper, which is good. But we want to keep doing it till beepers are there. And we have to keep on walking on the beepers. We cannot be right over here. So after picking up the beeper, we have to somehow, turn around and go back to a beeper so that we can run it in a loop. And the loop will be while beepers present. So while beepers present, we have to, pick beepers. Now to pick beeper, we have to first of all think, how can we pick the beepers? And then we have to move as well, and then pick beepers again, move as well, pick beepers, move, pick beepers. So let's start by moving, isn't it? So let's start by moving, while we are on beepers, while beepers present, and let's say front is clear. If front is not clear, let's not move there. Otherwise it will collide. So while beepers present and front is clear, let's move, isn't it? And this is our movement, which will keep going back and forth. So it will keep on going back and forth. Keep the movement. So that we can pick up all the beepers until and unless there's no beeper left to be picked up. So let's pick beepers. How can we pick beepers? So we can say if beepers present, we can start by collecting beepers. So we can say pick beeper, which we already did, if you remember it. While creating this function itself, we have picked the beeper. All right, so what this does, let's remove this assignment. So it tries to see whether beeper is there. If it is there, it tries to pick the beeper. If we are on a beeper, it tries to move back and forth. So let's see. There's a typo, that is if beepers present, I guess. Yep, there should be a S, beepers present. Yep. But after picking beeper, we were no longer on beeper, so it stopped. We need to be on beeper if there is any. So let's define certain helper function, that is turn around and for I in let's create turn right as well because we need it. Turn right is nothing but 3 times turn left. All right. Now we can probably use, turn around and all. So after picking up the beeper, it is facing this way, which is east. It should turn around actually. And after turning around, it should move so that it is on the beeper. Now let's see what happens. So it was on the beeper, so it went to the another furthest corner and it picked up the beeper, and then it tried going to the farthest corner again, but there was no beepers to pick. So if there is no beeper to pick, we can assume that there exists a beeper before that because it was walking on that. So we can come up over here in else and try saying something like else. If you can't find beepers, just turn around. If it turns around and moves, it is going to probably find a beeper. So turn around and move. And if you find a beeper, pick that beeper. And after picking the beeper, you should move again in the direction so that you are already placed on another beeper you can pick. So let's see if it runs. What is the typo? Else. Oh, else is not a function, so we should not do this. I am sorry. Yep, nice. Nice. It is because of else. And now this is gone. So this is gone and we are off by 1. We are off by 1. So what should we do? What should we do? Well, we have to somehow, we have to somehow face east and move 1 step so that we are on the middle, because we are off by 1 in every case, I guess. If we are not over here, then if we are not in middle over here, we probably are not in middle anywhere in any word. So let's do it over here as well. Since beeper is no longer there, we don't need to pick up from the far ends. So we can, create another function, but let's do it over here as well so that I don't need to create another function. What is it? It should be put the last beeper in middle. And for that, we need to go to the middle. Go to midpoint. Oh, not 4, but go. All right. Now to go to the midpoint, what I see is we should first of all turn around. We should move, and we are already on the midpoint. And now we can try putting the beeper. Put beeper. So we can say put beeper again. And this probably would have put the beeper on the midpoint, I guess, I hope. So let's see. Yeah, so it's going to, yeah, so it did put the beeper at this position. And there was an error we got. Let's see what the error is. Let's speed it up since we know how it works. Let's run it. So there's an error that's saying 6x6 world is not finished. So let's go to 6x6 world now. Let's see what is happening over there. Okay, so it is choosing this one as a middle point. Or it is still saying 6x6 is not done. It can be because of orientation, yeah. So most probably always face east. That's orientation error. Yeah, see, now it is seeing the westward, so it needs to face east. So we can create a function that is called face east. All right, so we will have to create a last function that is face east, which will always make our Karel face east. All right, so to do that, we can use a condition that is there in the docs. If you can see that there is a condition. These are the conditions that can be there. All right, so we have to be limited inside these conditions. So there's a limitation, and it's like a puzzle. You cannot go beyond these rules, which is nice. So there is a condition like not facing east. So while not facing east, we should try turning the left because it only knows how to turn left. So not facing east, not facing east. This is the condition, which can be either true or false. In this case, it is false because it is facing west. It should try to turn left, and it will probably face, after turning left, it will probably face south, and that is also not east. So it will probably turn left again, which will be east. So let's see. Let's run it faster. And it faced east. See? And it also worked, which is awesome. Nice. I love it. Let's keep it at the end because that's a helper function. These all are helper function. These to fill the row and remove beeper from far end are the two functions that are main. All right. So this one is orientation. Final orientation. Final orientation, and since we are done, let's run it a little bit slowly so that we can appreciate the beauty of this program. It's running, it's working, looks nice. And then we'll end this Midpoint Karel and we'll probably go to the checkerpoint or checkerboard, not checkerpoint, checkerboard problem. All right, so we are at the midpoint and it's done. So let's move to the last problem of this week. That is the checkerboard problem. And these two problems, remember, midpoint and checkerboard were some challenging problems. Even I took like a lot of times. All right, so now this problem requires us to create a pattern, something like this. So let's create those patterns. So we don't know how to create checker patterns, but we are very familiar with just filling out this whole beepers. So let's start by, filling out the whole row with beepers. So while front is clear, now we are very familiar with this, how to do this. Front is very clear. We can move and put beepers. So we'll probably put beepers first because our first position also needs beeper. And we'll move as well. All right, so we are very familiar with what it does, and this will not actually fill the whole row. It will leave out the last one. So we have to say put beeper. It's a fence post problem again, or off by 1, as we can say. And this will fill the whole row. All right. Now, since we have filled the whole row, we can, do something like move and put beepers, move, put beepers, something like this. What is it? Oh, it's a function, so we need to use parentheses like this. And now it sort of creates a checker pattern that we think we like. So after, getting in a hand of, creating checker pattern, you need to go to the next row and create the checker pattern again. So there are various ways you can do this. So let me just discuss the strategy. Let's first escape, reset it, and let's discuss the strategies, how many times or how many ways we can do this. But I'll only discuss one of them. All right, so let's discuss the one that I'll be using. So I'll fill out this row with checkerboard pattern. I'll come back. All right, I'll move to the next row. I'll fill this one as well. I'll come back. I'll move to this next row, do this again and again till it reaches this position where the left is clear. Left is no longer clear. And for this last one, we'll just lastly fill the checker pattern, probably come back. And if it needs us to be at home, we'll come back to the home. All right. So we need to encompass these two movements as a one function because, we need to come back, and it's good if we can just come back to home first, and then as a second function, we can just come back to this preset position. All right. So this is our first strategy. The second thing you could do, you should try it on your own. Fill the checkerboard over here, go upwards, try filling it like this because it's facing west, and you can probably try a different pattern. Move upwards, try doing it over here. It's facing east. This now face west. This now face east. This now face west. And now, since it is on a world of 6 by 6, it is good. And you can say while right is clear, you can do this. If it is not, you can get into fence post problem. But as soon as you change the dimension of this world, this will become more confusing than it sounds. All right, so The another thing you could do is I've seen people do something like go upwards, make checker pattern, move this way, do this over here, make it like this, isn't it? And I've seen people do this. I also thought about something like how about we know how to step up, so we can step up like this and create a checker pattern. And then after stepping up, we can just move to the next one and start stepping up. And wherever we step up, we should probably put a beeper there as well. And then we can move over here and start putting beeper over here as well. So it was like nice. We can come back to many strategies, then come back home, do this for this one, and come back home again. Now it becomes more complicated. So I'll try to follow the first easy one and let's see what happens. All right, so the checkerboard, let's start. So how about we start by creating a function that creates the checkerboard pattern. So let's define checker checker row. But yeah, let's first of all create checker row where we paste this whole thing. Oh, indentation error. So what just happened right now? All right, so we need to create a checker from empty corner. So like we are at the empty corner and we have to create a checker pattern that should look something like this. All right. And I hope that it creates the checker pattern. Oh, we need to call it as well. So let's call it in line 9, that is checker pattern from empty corner. And let's see what happens. So it tries creating it. All right. And the front is blocked and over here it crashes. So it should be like safe move, isn't it? So let's define safe move as well. And with safe move, we should define turnaround and turn right as well. So let's define safe move. We know what safe move is. We have used it earlier as well. It is nothing in docs as well. It is given to us like if front is clear. If front is clear, we can try to move. This is safe move. You can see it over here. Where is it? While front is clear, you can move, but for safe move, if front is clear, you can move. So it checks whether it can move or not, and then it can move. So if we try to do this, also we got 2 beepers. Why did we got 2 beepers? Let's see. So it was on the while loop, running. Oh, so this one also puts the beeper. All right, so let's remove the last, put the beeper line. And I hope that will remove this problem of putting an extra beeper at the end. And it works. All right. Now we somehow need to come back. So like return to home. All right. Return RETURN home. So let's define what return home is. Did I define? Oh, before defining these, let's define turnaround and turn right because we are going to use them. And I said I will define it. And we are already familiar with turn around and turn right. All right, so we can now define return home. That is nothing but turn around. And then while front is clear, we can tend to move. So it moves. So it turns around and while the front is clear, it moves. It should also face east. So we should say turn around again. And this would look nice, I would say. And after returning home, what we should do in main is ascend, isn't it? So let's create a function called ascend and define ascend. What is ascend? Ascend is nothing but after it is facing east, that it should face east. Why shouldn't it? It should turn left and then it should move upwards if possible, and it should turn right again so that it can start filling the rows. So if we do this, let's see what happens. All right, so it ascends and now it needs to, do this checker from empty corner again and again. So let's use a loop. What loop should we use? Well, we should use while loop. That is, if left is clear, we should do this again and again. What should we do? Well, I hope we should do this. And indentation error. Let's do this. Let's speed it up, and I don't see a checker pattern. Well, this looks like a pillar, but not a checker pattern, and it stops right over here. All right. So there's few errors that I think is there. We first of all should start from put beepers and all those things. So what we can do is we can start by saying putting beeper, and then instead of saying checker from empty corner, let's cut this and we can say checker row, which is a more generic way. And let's define the checker row, which will be nothing but checker from empty corner and returns to the home. That is as a one step. All right. Now checker from empty corner should be only used if our Karel is not stepping on a beeper. Let's reset it and put a beeper. Stop. Let's imagine Karel is standing over here. So it is on a beeper and it started, creating checker from empty corner. So it thought this was an empty corner. It didn't have anything to verify. So we can let it verify if beepers present. All right. Now this will verify whether beeper is present or not. If beeper is present, then first of all, move and then create checker from empty pattern so that you can be on an empty, corner, and then you can start creating checker from empty corner. Otherwise, else, if beeper is no longer present, like in the second row where the beeper will be not present in the first one, it should start doing what? It should first of all, create checker from empty corner as usual. So we should see the real pattern coming up, and we see that, so we see that for this one and the second one, but from third one, we are making some sort of mistake. That is, we are ascending, but we don't know whether we are starting on from a beeper or not. And if we are not, well, we should put a beeper in an odd even pattern. So how can we do that? Well, we can first of all, instead of just ascending, we can ascend and check whether we should put a beeper or not. So we can do something like this. Instead of directly using ascend, we should define a function that is called ascend ascend and check. Let's call it ascend and check. So it does, instead of just ascending, it checks also. So we are ascending after checking. So like if beeper is present, which means if we are ascending from here, we are at home and we are ascending from here after ascending and checking. So if beeper is present, we should move and do nothing. But if beeper is not present, we should put a beeper. So if beeper is present, we should just ascend normally. Else, like if beeper is not present, we should first of all ascend, and after that we should put a beeper. All right. So this works, and it actually did. But for the last one, that is over here, it has to create the last checker row. So let's do that, and we are done. So let's run it and see. And so this is exactly what we expected. But now we want to return to this position. So let's call it return to origin. All right. So let's do this in a main only, so that write a comment like return to origin, which will do nothing, but it will turn right first of all. So turn right. All right. So to return to origin, first of all, turn right. Then while front is clear, we should move. So while front is clear, we should move, isn't it? And after moving, we should turn east. So we should turn left first of all, because it was facing southward and it moved, and now it should turn left. So to face east. If this does it, then we are good. If it doesn't, well, let's see. All right, so it says we did not finish the 3x1 world. Let's see what happened. Okay, so front was blocked. Where? In the line 25, the front was blocked. So instead of just moving, how about we safely move? That is, we just say safe move. And we have this function that we can use. So safe move. And it works. Nice. And we did it. All right, so let's check for 3x5 as well, whether it even creates the checker pattern or not. Well, it does. That's why we did it. Otherwise, mostly we face problem while, if we created 6x6, we face problem while creating 3x5 and so on. So this was it. And it was nicely done. So let's close this. And this is it for week 2. So I'll see you in week 3. Bye-bye.